do have time for a quick question? If, otherwise, well, Mike, why don't you come up, Mike? Yeah, no, come on up. Not any, all right. All right, so we're working out the format here. So do you have slides? All right. That's you. I'm going to just go right here. You need like a USB-C connector. Good. All right, so while Mike's getting set up, I'm going to introduce him. So our next speaker is a good friend personally and a good, great friend of the lab, Mike Olson, who's a graduate of our department. I met Mike when he was working on a system called Postgres, which, as many of you guys know, was a very influential database system that came out of Berkeley and was one of the systems that sort of convinced us in the AMPLab that we could have impact beyond the traditional academic venues. Mike is famous for a lot of things. He was the founding CEO of Cloudera. He's now the Chief Strategy Officer, I believe. And as I mentioned earlier this morning, he was always, from the beginning, a very big and vocal supporter of what we're doing at AMPLab. So welcome, Mike.
Thank you, Mike, and thank you for the welcome. I have to say, when Ben got up and the first slide he had, down to the bottom, it very briefly flashed, 1 of 76. I thought, oh my God, he's going to take all 90 minutes. I congratulate him for motoring through his 76 slides. I have noticed so far this morning that the game of the day is insulting Mike Franklin's slide design skills. I have used my industrial guile to avoid that fate. So Mike and I came up in grad school at the same time. We have the same absolutely abysmal graphical design skills, but more clever than he, this is my slide. I'm going to talk to this slide for 30 minutes, I think. But don't be alarmed at that paucity. In fact, I've spent more time on this talk than I do on most. I've spent better than a week getting my thoughts together and writing it. This is a rare opportunity. To begin with, I'm kind of the proxy for the companies in the audience today. Cloudera has been involved with the AMPLab since the very earliest days. We were aware of the projects that fed the AMPLab, both Mesos and Apache Spark, Spark at the time. And we were among the early startup sponsors of the laboratory. We used that relationship to our tremendous unfair advantage. So we've had a great stream of students come through Cloudera as interns over the years, working on important projects in the summertime. In fact, Matej Zaharia, one of the key contributors to, really the creator of the Spark project, spent a couple of summers with us learning everything that was wrong with MapReduce as he decided what the architecture of Spark ought to be. And that's been very good. It's been a great way for us to get insight into the research that the team was doing. It's been a good way for us to keep track of forward-thinking, important trends in the industry, and it's been a real great well of extraordinarily cheap, very talented young people who come and motor away on our products for a summer or two. So, Mike, thanks a bunch for that. We appreciate it. We've also attended the retreats. We've gotten to listen to these ideas be born, mature, and often launch out of the laboratory. That has been a very valuable thing for us to do, and I know it has been for the sponsors in general. We've not only watched it, though, we've been adopters of the technology. You'll hear all day, you've heard all morning, I'll talk again about the Spark project. Spark has been a very important part of, has become a very important part of the work that we do at Cloudera. So we've benefited directly by taking research work out of the laboratory, bringing it into industry, delivering it to customers, finding ways to both invest in and monetize that technology as it's grown beyond Berkeley. And that's been absolutely fantastic. But not just Spark came out of the lab. The lab has had a huge number of very important projects that have led to new insight and that have driven new thinking across the industry. A couple of significant examples, and again, I'll talk about them later. What had been T-Rex, then became Tachyon, is now Eluxio, distributed memory shared file system. Very interesting architecture for big data, and the Mesos project. You may know, many of you, that when Cloudera began, we commercialized the Apache Hadoop stack. So we brought this big data platform built on HDFS, a sort of Google file system-alike implementation, and MapReduce. We brought that to traditional markets. As engines like Spark and HBase, this NoSQL store, kind of got added to the mix, it became clear that resource management was going to matter. And I've said this publicly before, but I'll repeat it here for this group. Early on, Cloudera was crazy mad in love with Mesos for resource management in the Hadoop ecosystem. And candidly, I think, had we been solo, we would have chosen Mesos to provide that service inside the Hadoop ecosystem generally. At the time, of course, we weren't the only players in the Hadoop space. There were a bunch of big web companies that were contributing substantially, not least Yahoo, a very big team doing very good work. There was a project in development at Yahoo called Yarn, yet another resource negotiator or navigator, that clearly had the emotional and institutional backing of that big company. And we made a tough decision. It was kind of a Betamax VHS decision at the time. We liked Mesos better, but we thought that if we chose it and Yahoo chose Yarn, we would launch a civil war in the Hadoop ecosystem. And every single engine that wanted to get added, Spark and HBase, and later Impala and the search stuff we've done, and all of the other third-party engines that have gotten added, would have had to pick one or integrate with both. And it would have fractured that ecosystem. We made the intentional decision at the time to get behind Yarn. We've been big contributors to that project since. But history might have played out differently had there not been a competing project with some commercial backing at the time. In addition to Spark, to Mesos, to Tachyon, of course, a long list of outstanding projects, particularly distributed systems projects, Akaros, GraphX, MDCC, MLBase, Pickle, Sparrow, Splash, and Coco, all doing interesting work, many of them, by the way, touching on machine learning. You've heard about that this morning. I'll talk more in a little bit. But then, in addition, unrelated projects. And one I want to highlight in particular, an area of research that I think doesn't get enough attention because it's very hard to do well. Work on characterizing real-world data center workloads. If you want to build a scale-out data center, if you want to design a good server or rack-mounted system or broad data center, you really want to understand what workloads are realistic. That's fantastically hard data to collect because Facebook and Amazon don't want to share their internal data center workloads. But there's been some great work as part of the AMPLab on characterizing that. There have also been a collection of interesting, what I think of as sidecar projects. They take advantage of a bunch of the big data and scale-out processing that the lab has worked on. And they're centered around genomic workloads, so cancer tumor genomics, DNA processing pipelines, SNAP for alignment. Using these technologies for important research and social problems has been fantastic. And again, in the context of RISE, near the end of the talk, I want to come back to that. My job, you'll see, is to talk about the commercial impact of the lab on industry. And I'm pretty well positioned to talk about that in detail. I would say that, you squint your eyes, it may be that my company has benefited more than any other from the work that has been done at the lab. Spark, first and foremost, has been fundamental, as I said, to what we do. But then in addition, it's not merely the Spark project, which founded Databricks, a spin-out company that's done well. Jan led and continues to lead that effort. But other companies as well. Aluxio is now a funded company backed by Andreessen Horowitz. Mesosphere, likewise, a company commercializing the Mesos research done here for cluster management and provisioning, quite broadly. Lots of companies that didn't get funded out of AMPLab have nevertheless benefited. Cloudera, I've talked about, got some competitors in the big data space, MapR, Hortonworks. Likewise, they've benefited from the work. But huge companies, a number of them sponsors of the lab, have taken advantage of these research projects. IBM, Amazon, Microsoft, Apple, SAP are all using code that was born here at Berkeley to run their businesses, to understand their customers, to deliver their services better than ever before. All of us as sponsors have benefited from our exposure to the work done here. We've taken advantage of the code. An often under-realized benefit, though, is also the fantastic pipeline of talent that comes out of a laboratory like this one. The students that graduate, the work that they've done, the lessons they've learned have then gone on to industry, taken jobs, even if not in startups, in promoting that knowledge quite broadly. So the pipeline of talent coming out of the laboratory has been absolutely fantastic. I want to shift gears a little bit and talk some about the opportunity looking forward. What should AMPLab teach the RISE lab? And in order to give you guys that perspective, I feel like I ought to explain myself a little bit. You ought to know who I am and what biases inform my views on that point. So, I'm a rare bird at the University of California, Berkeley. I have an undergraduate degree that spans 3 decades. The 70s, the 80s, and the 90s, I paid undergraduate tuition to this fine public institution. There were a couple of serial dropout events, I admit, in the middle of that, but I was an undergrad longer than even some embarrassed grad students were grad students. I got my bachelor's in 1991, my master's in 92. I dropped out of Berkeley, I like to say, for the last time in 1993 out of the PhD program to join a company commercializing some research that happened. The projects at Berkeley that made a difference to me, that informed my career, very earliest days, late 70s, early 1980s, of course, Berkeley Unix. And I would compliment Bill Joy and Bob Fabry back in the day, but also Keith Bostick and folks like Kirk McCusick for creating the Berkeley Unix and creating a Berkeley view of what open source software was. Quite different, I should say, from the view out of MIT promoted by Richard Stallman, which was much more coercive. Both of those views continue to survive and thrive. Both have matured substantially. But some of the very earliest open source work that happened was on Berkeley Unix here at the university. And then, of course, personally, I worked on the Postgres project and on software that became Berkeley DB. Both of those have been a big contributor to my professional success as well. Related work at Cal that wasn't mine, but that informed some of the projects I got to work on were the RISC work, reduced instruction set computing, and RAID, redundant arrays of inexpensive disks that created a real generation of new thinking in systems architecture broadly. We've talked a little bit about how to create and run a laboratory. What were the lessons that fed the AMPLab? I think it's fair to call it the Patterson Model, although Randy is in the front row as well and was fundamental in creating this model. But collaboration among teams, institutions, departments with a fixed lifetime with pretty clear goals on direction. In my time at the university, the most meaningful of those was a project called Sequoia 2000. And this was in the early 1990s. The goal was to take the work on Sprite and the log structured file systems and Postgres, apply computer science research to global climate change. Remember, this is the early 1990s. Global climate change really hadn't happened in the popular imagination yet. I would say, in the large, that effort was a crashing failure. We did some interesting work, but here in 2016, we're on the precipice of a very important crisis, and I think it might be good to refocus the community's attention on those problems. Long way to tell you that I think I've got a good background in history of Berkeley and these projects. One of the core things we've always done well here is to build and to ship. This is the finest systems school on the planet, bar none. We have been building and shipping software before anyone else. And the systems we built here have been fundamental in moving the industry forward. The work that the AMPLab did in promoting open source, as hard as you heard Jan talk about, has built on that legacy, and I think it's a great legacy to carry into RISE. Personally today, I actually spend a couple days a month on campus. Part of it is just to walk around and talk to interesting people, kind of keep track of what the cool kids are working on these days, and try to keep myself from turning into an old guy. But another is to foment entrepreneurship. And you heard Paul talk this morning about the importance of entrepreneurship out of Berkeley. There's another lesser school about 40 miles south that has a really good reputation for entrepreneurship. But I'd argue that Berkeley has actually done more of the interesting and innovative research to foment innovation than anyone else. Steve Blank, by the way, has a fantastic talk about why Stanford has done all this commercialization and Berkeley relatively less. And it goes all the way back to the decision to do classified nuclear research at Berkeley and non-classified radio and radar-style research down at Stanford during World War I and World War II. So if you haven't seen Steve's talk, I highly encourage you to take a look at it. Part of the drive for me to foment entrepreneurship on university is when I was a grad student here, there was effectively no collaboration between the B school and the engineering school. I later became a manager and an executive at a series of startups. I was the CEO of Sleepy Cat Software, the Berkeley DB company. That's a terrible place to learn finance. We should really figure out a way to teach people that before they have to learn it the hard way by screwing things up in production. So I've been spending a lot of my time trying to encourage those two camps of the university to work well together. Over the course of my career, I've been very fortunate. I've been quite commercially successful. The projects that we've worked on have been foundational to that success. So Postgres has been very, very good to me. Berkeley DB has been very, very good to me. Spark, I trust, will be very, very good to me. But I want to emphasize this because it's really important, and I want to talk now to the students and to the faculty that are on the brink of creating the RISE Lab. We didn't do the work on those projects because of the economic opportunity they represented to us. We didn't do it for the money. And that's a very important lesson for you to take forward. I tell this story to students all the time. We're a fantastically fortunate group of people living at exactly the right time in history. If you're in this room, it's probably because your brain is wired to produce code. If you had been born in the Middle Ages and your job was to hoe potatoes, that skill would have gone unrecognized and unexploited. Lucky for you, there's a way to turn that skill into software and a good income. Given who we are, given the time we live in, I promise all of you, you're going to retire quite comfortably. Some of you probably get to be rich. The fact of the matter, though, is that you should focus on interesting and important problems because you can rely on the money to happen one way or another over time. you're never going to get the days back that you spend working on the problems that you choose. You should choose interesting people. You should choose interesting research problems. I believe the AMPLab did a fantastic job of biting off interesting and important problems. As we prepare to launch the RISE Lab, there are some important changes in the industry that I think we all need to pay attention to. This institution has to think 4 standard deviations out on the technology and society curve. There are problems that it's obviously commercially important to solve. Those problems are going to get ridiculous investment from the rich vendors in the space. And frankly, the University of California at Berkeley is not going to be able to compete with Baidu or Google or Facebook in driving dollars into commercially valuable problems. So we should choose the stuff that isn't obviously economically important, or that's so fantastically difficult to think about that commercial folks just aren't going to run the risk or spend the time. We should do only the work that industry can't do. When I was coming up, Bell Labs was the center of the universe, man. We all thought that when we graduated, that was where we wanted to land. Bell Labs did fantastic foundational seminal research and was an outstanding partner to the university in the work that we did. Berkeley Unix drew heavily on the work that Ken and Dennis and others did at the labs, and there was fantastic cross-fertilization. And there can and should be fantastic cross-fertilization between the RISE Lab and institutions like Facebook and Google. But we should choose the things that they can't work on well. I'm guardedly pessimistic about Berkeley's ability to do any really innovative or foundational work in data-driven machine learning. And it's just because Google has an unfair advantage, you guys. They've got the data, and we don't. So we should be thinking about the areas of ML that aren't getting their attention. What new algorithms ought we to create? How should we think about the social impact of artificial intelligence? Are there ways that we could apply AI to important problems like equity or privacy or global warming? Let's attack those as part of what we do. The name RISE, Real-Time, Intelligent, and Secure, touches on trends that matter enormously to industry. And I promise you, Cloudera is going to be plowing money into those areas in commercially driven, product-focused research. So the university needs to find places that we and companies like us won't focus. Secure Internet of Things is a promising area. The recent spate of DDoS attacks that have hijacked vacuum cleaners and cameras to take down big fractions of the internet, you know, that's really important stuff for somebody to think about, and I guarantee you that the vacuum cleaner and camera companies don't give a crap. So maybe at the university we can do that. I think there may be ways to think about cognition. Beyond simple data-driven machine learning, can we try to understand how the brain functions? Can we try to mimic that or build some reasonable analog in silicon? I think RISE has got a rich future. I think we need to choose problems that are important and hard and no one else will work on. In the early days of Spark, it wasn't that companies like Cloudera were going to make a bunch of money off of it that made it interesting to Matei. It was a hard problem to solve, and nobody else was paying attention to it at the time. Some of the projects that come out of RISE, just as some of the projects that have come out of the AMPLab, will be economically meaningful, but we should never, ever be driven by that goal. I'm looking forward to the next between 5 and 8 years, depending on how you guys work the funding lines of research that comes out of this. We at Cloudera are optimistic. We're excited to be part of that future. I know that a bunch of the companies in the room join me in that. Thank you all for your time this morning.